Now let's look at solving polynomial inequalities. So polynomial inequalities can be solved by using a graph or test values. So here we have one. The polynomial in question is going to be the p of x equals x plus 3 times x plus 1 squared times x minus 4. And if we were to graph this, and I wish I would have written that in red and blue instead of red, but whatever. Of course, look at x plus 3 equals 0, x equals negative 3. So that's one of our intercepts. X plus 1 equals 0, x equals negative 1. Of course, that was squared, so that's multiplicity 2. Then we have x minus 4, so x minus 4 equals 0, x equals 4. So that means it's going to be over here. Now, this is x squared, so that's x cubed, times x, so it's x to the 4th overall. And what we're really after is just the general behavior. We're not looking for specific values except for those intercepts. And so given that it's 4th degree, positive leading coefficient means it's going to be going up. It's going to be going up. And then this is a single 0, so it's going to come down. This is a double 0, so it's going to touch and go back down. It's going to cross over there. So what we're looking at now is places that satisfies this inequality. The inequality wants to know when it's bigger than 0. So being bigger than 0 means being above the x-axis. So these intervals that we're talking about, let me go to another color. How about green? So it looks like this interval here and this interval here are places that it is above the x-axis. So we would say that x plus 3 times x plus 1 squared times x minus 4 is greater than 0 whenever at negative infinity up to negative 3, union that with 4 to infinity. And that's it for that one. Okay, now this next one, it says find the domain of this, and this basically that what we're asking is where is 6 minus 5t minus t squared greater than or equal to 0? And for me, it's easier to write this as negative t squared minus 5t plus 6 greater than or equal to 0. And it's even easier for me, it doesn't mean for you, but for when I see this, if I were to divide everything by negative 1, of course, it's going to make this sign change. It's easier for me to factor this if I have t plus 5 minus 6, t squared plus 5t minus 6 is less than or equal to 0. Remember, when we divide by a negative or multiply by a negative, it changes the sign. And this factors to be t plus 6 times t minus 1 is less than or equal to 0. So in this case, I'm going to use t for test value, the test value method. So if I say t plus 6 equals 0, it means t equals negative 6. If I say t minus 1 equals 0, t equals 1. So those are my test values. Or those are my boundary values, I should say. So if I look at this in terms of and we do it this way, t plus 6, t minus 1. Now the smallest of our boundary values is negative 6. And then the bigger one is 1. We don't have any more. If we had more, I'd list them in order from small to large. So the test value would be saying, okay, fine, give me a number smaller than negative 6. And let me change my colors here. My menu went away. Okay, so I'm going to go like negative 7. And then when it's possible, I'll pick 0. 0 is easy to use. I'll go 0. And then bigger than 1, okay, 2. We don't have to get crazy about this, but we can have some freedom here. So let's put negative 7 in that first one. Negative 7 plus 6 is negative 1, so that's a negative. Negative 7 minus 1. Oh, we're looking for it to be less than or equal to 0. Okay. Negative 7 minus 1 is negative 8, so that's negative. So a negative times a negative is a positive. So, we're looking for it to be less than 0, so that's not going to be it. Then put 0 in. 0 plus 6 is positive. 0 minus 1 is negative. So 0 plus 6 is 6, which is positive. 0 minus 1 is negative 1, which is negative. A positive times a negative is a negative. That actually fits with our criteria. Now let's try the 2. 2 plus 6 is 8. That's positive. 2 minus 1 is 1. That's positive. So we get a positive out of that. So the only place this is satisfied is going to be from negative 6 to positive 1. So, and this, they can be equal to it, so the equals. So negative 6 to 1 is the domain of this function. Okay, and they use the whole concept of domain to get us to finding the inequality of a polynomial. Okay, we've got one more of these. Solve the inequality x to the fourth minus 2x cubed minus 3x squared is greater than 0. So again, let's look at p of x is x to the fourth minus 2x cubed minus 3x squared, and we want p of x to be greater than 0. And so we can do either way, a graph or the test values. And I'm not sure what you prefer because this is a one-way communication and in real time. So you can always post what you think is better. And it's really a personal preference. So x squared, I can factor that out, and we have x squared minus 2x minus 3. Oh, that looks factorable. So x squared times x minus 3 times x plus 1. And so these zeros are going to be x equals 0, x minus 3 equals 0, so x equals 3, and x plus 1 equals 0, so x equals negative 1. And this one's a double root. So multiplicity 2. So it looks like it's crossing at negative 1, at 0, and at 3. And it's x to the fourth, and it's a positive leading coefficient. So it's going to be going up from here and up from here. It crosses because this is an odd root, so 1. This is an even root, so it's double root, so it touches there and goes back down, comes back up. And then this graph is not necessarily accurate. But what we're after is what's above the x-axis and what's below. And so we want to know what's above the x-axis. So again, so this here and this here, that's going to be negative infinity up to negative 1, union that with 3 to infinity. Okay, that was a little bit long video. I apologize. Our next video is the intermediate value theorem. Some really cool stuff.